Dear students, so in this video I'm still continuing with first chapter real number, and I'm about to start exercise 1e. uh, for that exercise 1e, the related definitions, rules, concepts have been explained nicely in video number 26. Now in this video I'm going to quickly give you some bit of idea about the decimal form of rational number as well as irrational number. Now I've already told in the last video that for exercise 1 we need only the decimal form of rational number, because we don't have questions on irrational number. But then there's a saying that little knowledge or half knowledge is always dangerous. So if we have some knowledge about rational number, the decimal form, then it's always better to have decimal representation knowledge of irrational numbers also. Okay, so let's begin and then we'll start the exercise straight away after this. Okay, so let me just quickly revise or recap what we have done in the previous video about decimal representation of rational numbers. As you know that rational numbers are those numbers which can be expressed in the form of p by q. All rational numbers like 2 by 3, 4 by 6, 8 by 9, whatever, minus 8 by 9, whatever rational numbers I give you, all the rational numbers can be changed to decimal form. In fact, keep in mind, real numbers are of two types, rational and irrational. And rational numbers and irrational numbers both have decimal form. Okay, so what kind of decimal form this rational numbers have? Okay, so we have seen that, see, with the help of this table we can understand all rational numbers have one of these decimal form, either one. So means rational numbers have two kinds of decimal form. The decimal form of rational number can be either terminating decimal expansion, terminating, as I told you, terminating means something which ends. There's a beginning, but there's end also. Terminating decimal expansion, the decimal expansion which ends after some digits. And the other form of rational numbers, the other decimal form of rational number is that some rational numbers have non-terminating, means the decimal form is non-terminating, not ending, but repeating. They repeat. There's a recurrence, okay, of decimal digits, okay, of some digits, okay, or particular group of digits, okay. A particular digit or particular group of digits repeat, okay. So means these kind of two decimal forms rational numbers have, okay, either terminating, having end, or non-terminating, no end, but repeating, repeat, recurring. So what are the conditions? I've explained in the last video also. What are the conditions for rational number to have terminating or non-terminating but repeating decimal? And these are the conditions, okay. If a by b is a rational number, suppose a by b is a rational number where a and b are integers and b not zero. If a by b is a rational number, then to find whether that rational number has terminating or not, terminating decimal or non-terminating, for that rational number a by b, you just do the prime factorization of the denominator b. You just find the prime factorization of that given rational number b. Find the prime factorization of the denominator of that rational number, okay. Find the prime factorization of b, okay, the denominator. If the prime factorization of b, if the prime factorization of b is equal to in this form, that means that if b is in this form, if b can be expressed in this form where you have prime factor of only 2 or only 5 or both, combination of both, with powers such that m and n are non-negative integers. The powers m and n can never be negative. They can be 0 or they can be positive numbers, okay, integers, but not negative, okay. So if the denominator b for any given rational number, if the denominator b can be changed in this form, then confirms that this rational number has terminating decimal expansion because the denominator is in this form. And if a by b is a rational number, then if b, the b denominator of that rational number is not of this form, that means what, when you do the prime factorization of the denominator b, b doesn't come in this form. That means what, in simple word, besides 2 and 5 or besides 2 or 5 there are some other prime numbers, or even if 2 and 5 are not there, but there are some other prime factors like 3, 7, 11, 13, no, prime numbers, remember, prime factors. If the denominator are in this form, that means what, it is not exactly this form, but it is some other form, not this form but some other form. If b is not equal to this form, 2 to the power m into 5 1, then that rational number, if you divide, no, numerator by numerator, you'll have a non-terminating but repeating decimal expansion. Okay, this I've explained you in the previous video also with these two examples. Say example 7 by 8 and 7 by 6 both are rational number because p by q, where p and q are integers, q not 0, okay. See, 8 is denominator, 6 denominator, but say they are not 0 and both are integers, so both are rational number. But see, I've already explained in the previous video that 7 by 8, when you actually divide or when you do this prime factorization of denominator 8, you'll find that denominator will be in this form. And see, if you divide actually, see its value is 0.857. Means I've told you in the beginning that all rational numbers, whether 7 by 8 or 7/16, you can change them to the decimal form. You can write them in decimal form. If you actually divide 7 divided by 8, you'll get this much, and 17 divided by 6, you'll get this much. And if you see very carefully, here is an example of terminating decimal, because see, after 0.875 there are no digits, means it ends in 5. There's a terminating decimal. But here, when you divide 17 by 6, the decimal form, look, you can see here the dots. That means what? It is non-terminating, and also it is repeating. Look, after 2.8 then comes 3, means 3 is repeating, and dot here means it's 3 repetition. Okay, the repetition of 3. It's non-terminating but repeating. Okay, clear? And if you change the 6 denominator, it will be in this form. If you change this 8 in this example, 8 denominator will be in this form. Okay, can be changed in this form. So understood? Just one thing I want to tell you, that when you write rational numbers in this way, non-terminating but repeating, you can also do like this. I can write equal 2.8. Now see which particular digit or which particular group of digits are repeating. That digit you can write only once, or that particular group of digit you can write once, and then give the bar over that number. Bar means that digit is repeating. It is non-terminating and repeating that digit. Okay, so that's why I can write here 2.83 bar. 8 is not repeating, so that's why 8 is not under bar. Okay, 3 is under bar, means 3 is repeating. Okay, so this is for decimal representation of rational number. But as I told you that only knowing about rational number is not wise. Okay, when you have knowledge of something, you should have complete knowledge of that. Okay, about that subject. So since we have done decimal representation of rational number, so let us see what is the decimal representation of irrational numbers. Like if I give you irrational numbers, you know what are irrational numbers? I explain you. Irrational numbers are those numbers which cannot be expressed, or which cannot be written in the form of p by q, where both p and q are integers and q is not equal to 0. I've explained you last time. Okay, in the previous video. So means irrational numbers are those numbers which you cannot express in the form of p by q. Okay, where p and q are integers and q not 0. These are irrational numbers. So irrational numbers examples are this one. See, square root of 2, square root of 3, square root of 5, pi. These are all irrational numbers. And here in this topic we want to see, if I give you a rational number like root 2, root 3, root 5, pi, these irrational numbers have what kind of decimal form. Okay, if you write them in decimal form, what kind of decimal form they have. Okay, what kind of decimal representation they have. Okay, so please see, irrational numbers always, see this word always, irrational numbers always have non-terminating, that means what, it will never end, non-terminating and non-repeating, and it will not repeat also, that is non-recurring decimal form of expansion. That means what, for any irrational number, the decimal form will never terminate, will never end. That means what, there will be dot 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 after decimal. You write some digits, but since it will not end, there will be dots representing continuity, and also it will not repeat. See, in rational number 17 by 6, after 0.8, 2.8, then 3 is repeating. So this though dots here, non-terminating but repeating, this rational number. But in irrational number, it is always non-terminating. Non-terminating means will not end. You will find dots in the decimal form. And plus non-repeating means a particular digit, a particular group of digits will never repeat. Okay, means what, it will be very, very unpredictable. You cannot say what will be the next number coming. Okay, because it's not repeating. Okay, so in tabular form you can say this, all irrational numbers have only one kind of decimal form. See, rational numbers have two kinds of decimal form. That's why there are two branches, either terminating or non-terminating but repeating. But rational numbers have only one kind of decimal form. This is always non-terminating, never end, and non-repeating and not repeating decimal forms. So this is the example. Look, these are all irrational numbers. These are all irrational numbers. and we're doing a decimal form of irrational number. So see, this irrational number root 2, if you find, it will take lots of time, but you can Google and search. If you press root 2 and the value of root 2 in your Google, you'll find the value of root 2 like this. The means what? It's 1.414213 and in this way look, you'll find that the next digit what comes is very very unpredictable, because it doesn't see the numbers are not coming in a very sequential or in an order way. Okay, it's very very unpredictable what will be the next digit. Okay, after 4 what is the next digit we don't know here, but there are some numbers. Okay, so we write here dot dot means what? The value of root 2 has decimal form like this, which is non-terminating. See the dots, these values are just up to here 4 written in, but in fact it can be more than this. The non-terminating and also non-repeating. Look, you don't see a particular group of number repeating. Okay, it doesn't say that 8 is repeating, it's just 8 two times, and after that it doesn't repeat. So it means it's non-terminating and non-repeating, non-terminating and non-repeating. Same here, root 2. Root 2 was, say root 3 value, sorry, square root of 3. If you find, if you search Google, up to some places you can find. Okay, you can do in your copy also, you can find. But then to find for more, in this Google search you'll find root 3 value is like this. Okay, and here also look, the value of root 3 doesn't end here because it's continuous. Okay, from here. Okay, non-terminating and also non-repeating. See, a particular group is not repeating. Look, okay, they may repeat this only 2 times, maybe 3 times, but then it's not coming. Look, okay, same here, the value of square root of 5. See, non-terminating and non-repeating. And pi, generally we use pi in what? Mensuration. Pi is a very very useful constant value. So 3.14159 in this way, non-terminating and non-repeating. Okay, so but you know one thing I want to tell you, in maths when you do some calculations, like later on when you do some subjects like height and distance and all, mensuration, maybe you have to put the value of root 2, root 3 or pi. So all this value we cannot put, no need to put also. So what it is that we take sometimes correct to 2 decimal place or 3 decimal place or 4 decimal place. Like suppose root 2 value I have to put somewhere in the calculation. Root 2 has come, square root of 2. I want to remove root 2 and write the value. Then the decimal value I can put 1.41 or 1.414 or 1.4142. So means we can take either 2 place, 3 place, 4 place. Okay, for these are rough values. Okay, not exact values. Correct to 3 decimal place, 2 decimal place, 4 decimal place. Okay. So we can take, so we can take 1.414, or we can we can take 1.4, we can take 1.4142. Same way root 3 value, so I can take 1.73 or 1.732, 1.7321, because if I can think that 5 is cancelled, then 1, or 2.266 or 3. You know, in mensuration you take sometimes pi value 3.14. These are rough value in only 2 places. Okay, 3.14. Okay, but the actual value is, okay, these are just approximate value to some particular places of decimal. Okay, so I hope you've understood the decimal form of rational number and rational numbers and irrational numbers. Okay, so in the next video I'll start with exercise 1e. Thank you.